Good morning, everybody. Thank you for hopping on to this month's Industry 30. I'm happy to introduce our speaker today, Mike Maxwell with VoltServer. Mike is actually on the West Coast, so he's up early today to give this presentation. I'm really appreciative for that. You do have the ability to ask a question, so if you have one that comes up, please feel free to unmute yourself or use the chat feature. This presentation is being recorded and will be placed on the chapter's website afterwards, so you can share this with your coworkers after if you'd like. If you have any questions in the meantime, please let me know. And with that being said, I'm going to turn it over to Mike. Take it away, Mike.
Thanks, Rob. Good morning, everybody. As Rob said, I'm Mike Maxwell. I'm one of the senior systems engineers for VoltServer. And I believe joining me online will be Roger Heil, who's our director of market development. But I'll give the presentation today. And just a little bit, I definitely don't want this to be a VoltServer sales presentation in any form or format, but it's kind of hard to talk about fault managed power systems without doing that a little bit, since we invented the technology a decade ago. But today we'll talk about fault managed power systems and the new class 4. And as I understand it, a lot of you folks have already gone through some of the NEC and UL training that's affiliated with fault managed power systems. So some of this will be a review, but you never know who's in the audience, so I wanted to be quite thorough. So just real quick, let's review the legacy circuit classes, class 1, class 2, and class 3. That way we can know where we've been and how we're getting to class 4. So as you probably know, the various classes to date are differentiated from each other by their power limitations. And when you think of class 1, you think of wiring in the walls of your house, and you have maybe a plug in the wall, or maybe you're at a commercial site and there's a large telecommunications style battery bank there with a big rectifier, and it's pumping out 48 volts DC through huge cables the size of your thumb. Well, class 2, as we know, is a more intrinsically safe wiring circuit method that uses a power limitation for its inherent safety. And you can think of that as power over Ethernet is probably the most common one, a standard class 2 distribution system that puts out 100 VA or 100 watts maximum. It's throttled. And class 2 was intended to be a safer power system that would control fire initiation and electric shock through its limits of power. And class 3 is very similar to class 3, as you probably know. It's just that it focuses on fire initiation. So once again, when you think of class 2, you're basically thinking of PoE or PoE on steroids. And Article 725 of the National Electric Code allows for special wiring methods for class 2 and class 3 circuits that differ from class 1 based on wire sizing and the types of protection that are used to protect those circuits. Probably the most important takeaway for everyone is that class 1 and class 2 and class 3 circuits can't share the same enclosure, they can't share the same raceway or riser, and they definitely can't be within the same cable. So when we're going to focus on today is class 2, because that leads to class 4. So class 2 is really the legacy of where class 4 came from, and we'll get into the details of how that migrated over here shortly. But if you look back in time, 1933 is when the NEC first introduced class 2 as a definition. And way back then, it was primarily intended for what they called signaling systems. So you think fire alarms or bank alarms, different types of power systems that weren't the traditional wall power, which was probably knob and tube back then. So that was the birth of class 2 as its own special classification. And then for the next 30, 35 years, they tinkered around with the definition a little bit within the NEC, but it was always intended to be a power limited circuit. And that's what it's defined as today, is power limited circuits and wiring. And once again, always intended to prevent risk of shock to humans and to control fire. So the current definition for class 2 comes from the 1996 National Electric Code, and that's where it clearly states a 100 volt amp power limitation. And some folks can't get over how you can actually run more power through a class 2 circuit than 100 volt amps, and you can do that legally per code. And to get into that a little bit, that's where I have to talk about VoltServer, because we pioneered the fault managed power system a decade ago. Our CEO invented the technology and patented it. And what we called our version of a fault managed power system is digital electricity. And what that really is it's an intelligent power system that allows you to use class 2 wiring, but exceed the 100 VA limit and exceed the voltage limits for that cable safely and per existing code. And the way that's done is it uses a limited power source, so a source of current that is intelligent and controlled as an advanced class 2 system. So no longer just a 100 VA system that's throttled over small cables, but an intelligent system that uses the same class 2 wiring, but does so by monitoring the amount of current injected into the wiring. So Article 725 of the National Electric Code says you can do this if you have a certified by nationally recognized testing laboratory limited power source as the source of current into class 2 wiring. You can do that. And the way VoltServer has been doing the fault managed power system over the past decade is by having that transmitter shelf, that source of current, certified to UL 62368-1, which is the audio, video, information, and communications technology safety requirement. And we do that by part 1. So we'll see where this leads in from the legacy of class 2 into class 4. Both are fault managed power systems, but a lot of folks nowadays, because of the 2023 NEC code changes, are just calling this class 4 when really it's truly fault managed power. So where does fault managed power fit in? Well, it fills the gap between the traditional high power levels of class 1 and the throttled, limited, intrinsically safe power levels of class 2, being basically 100 VA or 100 watts. So with a standard class 1 power system, you're looking at large breakers and fuses for protection. And the NEC Article 300 defines the wiring methods that you're all familiar with for putting in standard power in the wall of a house. And as we know, you have to have a licensed class 1 electrical contractor do that work. And class 1 power, because you can step up the voltage pretty high, you can run long distances. Or if you want to do a 48 volt DC system, it's very large wire sizes. So with class 2, as we know, a standard telco technician or low voltage electrical contractor can put it in. Doesn't require class 1 labor, but because of its lower voltage and lower current levels, it's a very limited range. As we mentioned earlier, NEC Article 725 defines the special wiring methods for class 2. So a fault managed power system takes the advantages of both class 1 and class 2 power and does away with the disadvantages. So fault managed power systems allow you to run high power levels. So if you have on a class 1 system, say a 50 amp breaker at 240 volts feeding your hot tub, well, you're getting a significant amount of power. There's about 12 kilowatts of power that's protected in that class 1 circuit. A fault managed power system, such as the one there you see in the middle, that is also a 12 kilowatt source of current, but it's intelligent power. So it allows the system to be installed on class 2 wiring per Article 725. So no conduits, no special permitting required. As I mentioned earlier, a low voltage technician can install it, but you still get that long range of power delivery. And you can use the small wires. You're looking at generally 14, 16, 18 gauge wire. So it crosses over the power supply availability of class 1 with the intrinsic safety of class 2. So in general, people bringing fault managed power systems to market will do it in their own methodology. But as an example, I can tell you how VoltServer's been doing it for the past decade, because it generally describes what you'll see in the class 4 listing in the National Electric Code or UL 1400. So a fault managed power system will take power off the mains, whether they're AC mains or a large DC input from a telco style battery bank. And then it will convert that power to class 4 in what's called a transmitter shelf. And that transmitter does the modification to the power. It also has all of the brains and does the control and monitoring of the energy that it sends out through the class 4 wiring. So the class 4 wiring is, as I mentioned earlier, is generally a small gauge multi-conductor cable. And the energy going through that, as I mentioned earlier, it'll vary by manufacturer, but what VoltServer does is 500 times a second, we send energy packets, hence the term digital electricity. And these packets consist of energy, so voltage and current, and then a safety validation of the wiring between the transmitter and the downstream device. And since that's done 500 times a second, that means that if any safety validation fails, if there's a short in the wiring, somebody's touched the wires, a tool has cut the wires and shorted them, that within 2 milliseconds, that energy is stopped. So even though there's a significant amount of energy, and in VoltServer's case, 336 volts pulsed DC, it won't hurt you. Because if you touch the wires, within that 2 milliseconds, all you'll feel is a small shock, like you get off of a static shock off your doorknob when you reach for your doorknob on a cold winter's morning in your stocking feet. So at the receiving end is a unit that we refer to as the receiver, and it decodes the digital electricity and then converts it into a class 1 format that's suitable for the type of load, whether that load needs 48 volts DC, whether that load needs a true AC sine wave, or if that device has a bridge mode power supply and needs higher voltage DC. So you basically, the components of this type of a system are the transmitter, the wiring between the transmitter and the endpoint, and then the receiver. And what this allows you to do is it allows you to have ranges up to 2 kilometers that the energy can be sent. And it's done through the small multi-conductor cables. So that advanced class 2 that we mentioned earlier, that is what has become the new class 4 standard. And the way it came about is in order to open up the playing field to all manufacturers, and in such a manner that it wouldn't infringe upon VoltServer's patent of digital electricity, the industry groups got together and said, look, we need to find a way to better define what's being done, because even though advanced class 2 exists, it's legal, it's permitted per codes, it's a little bit undefined. You have to chase your way through the codes to understand how it's done. So the UL team got together with VoltServer as a participant and many other industry leaders and said, okay, let's define what we're doing today, but open it up to everybody. And let's set some guardrails around this so that everybody can build a fault managed power system, but do it in your own way. So that's what in 2023 became Article 726 of the National Electric Code, was the culmination of the efforts of this industry group. And it was based on the group's development of UL 1400-1, which is the document that defines what a fault managed power system will be for everybody, and also a special UL 1400-2 code that has to do specifically with the cabling. And anybody that's gone through those two standards understands that it's primarily a manufacturer standard. It says, okay, if you want to supply this equipment and be compliant with class 4 in the NEC, you have to go through certification, listing. You have to, it's more of a testing standard. You have to, do what you say and say what you do. So it's about documentation. It's about creating a complete system end to end with all the parts from the same manufacturer that meet the tested and testing requirements. And for the cable manufacturers, it's the same type of thing. They have to go through, meet some special criteria for the cables. Some of the cable manufacturers were able to just restamp their existing class 2 or class 3 cables. Others had to go through and tweak them a little bit, but it has to do with the listing, labeling, and also batch testing. So every so many feet of cable that are produced by a manufacturer, they have to take some off the reel and run it through a full destructive test. So we're not going to get into the details of those two standards, but just know that they do guide manufacturers on how to make their products suitable for listing. So class 4 is basically the same as class 2 with regards to protection against shock and fire. It just has to do with listing and labeling primarily, and the deployment of a complete set of equipment. So a class 4 system does the same thing that VoltServer's advanced class 2 does. It monitors for faults and stops the power delivery if there is a fault. And that's really the 10-second definition that's at the beginning of Article 726 in the National Electric Code. There's a whole 3 pages that define that in the NEC now, but that's the gist of it. Is it's a system that monitors the circuit for faults, shuts the power off if it has to, and it uses the same wiring methodology as class 2. So if you're familiar with class 2, class 4 is 99% the same. Any questions so far? We'll also take questions at the end. So getting into Article 726, there's really 6 big takeaways from this. And that is to understand what a class 4 power system is. And that's, as I mentioned, it's an actively monitored and controlled system made up of transmitters connected to receivers through cables. And they define a class 4 device as all the devices in a class 4 circuit. So transmitter, receiver, or also what's defined as utilization equipment. What they mean by that is there are now some devices, loads, that have the class 4 receiver embedded directly into them. So instead of having to have the output of the receiver physically wired to some load, a radio or a PoE switch, for example, that utilization equipment has the receiver built into its head end. So you just plug the fault managed power cable into it. All the conversion back to class 1 power is done within that box, and then it performs as it's supposed to. So as we mentioned earlier, the transmitter is the device that's the source. The receiver is the converter of the class 4 power back into class 1. If it's embedded into a device, it's called utilization equipment. And the circuit is just the cabling between the transmitter and the receiver. So this is what it looks like as a block diagram. You'll see it's very similar to what I showed with the VoltServer standard deployment. You take your AC mains or your DC mains in, convert to class 4 power. That entire circuit is then protected through the intelligence of the transmitter, which is then also monitoring the circuit and may or may not talk to the receiver. And as I mentioned earlier, that receiver can power a load, or it may be embedded into the load. And these fault protections are defined within that UL standard, UL 1400-1. And this just shows how a fault managed power system is intrinsically safe. It stands up well to the existing types of protection, whereas a GFCI is only looking for line to ground faults, and an arc fault circuit interrupter can do line to ground protection as well, and also adds series and parallel arc protection. Well, UL 1400-1 says that a fault managed power system needs to go beyond that. It needs to protect line to line. It needs to look for high resistance line to line faults. And it also needs to be able to detect series resistive faults. So the intelligent power system is, as you'll see, is much more advanced than just the so-called dumb devices that are used traditionally to protect a class 1 type circuit. So without going through the entire 726 and 1400-1 definitions, the most important takeaways are that class 4 power currently can't be used in a home or an apartment. So we're not replacing all the wiring in standard dwelling units. It's used for specific applications, generally commercial or industrial. And the class 4 circuit voltages are limited to 450 volts. And by using the higher voltage, you have less losses due to heat and resistance in a cable. So it operates like a power utility system. You know, transmission lines operate at higher voltage than distribution lines, and that is for efficiency, so you can push the power farther. The output of a class 4 system is considered in the codes as a separately derived power system if it's being used as a branch circuit or feeder. The VoltServer applications don't do this. We do engineered designs where we know exactly what load we're serving. We're not just replacing a plug in the wall, but a class 4 system can replace a plug in the wall. And if so, it has to be labeled similar to a generator as a separately derived power system, just for labeling purposes. Also, all the receiver output circuits have to be marked as class 4. So either on the receiver itself, or you have to physically attach a label that says this circuit is a class 4 circuit, and it has to list the voltage and current, or just the power output of the class 4 circuit. Because as we can see here in the chart, you know, as we mentioned earlier, class 4 circuits, fault managed power systems do provide a lot more power than the traditional PoE that people are used to on class 2. Whereas PoE might have 90 watts feeding in, and you might get 70 or so on the output. And a standard class 2 system can start with 100 watts, and you might get 95 at the output. As we talked about this earlier, generally you're looking at 600 watts on a pair of conductors in a standard fault managed power system. So each manufacturer will do it a little differently. We'll all have our own secret sauce, but for the VoltServer philosophy, we design to a maximum of 600 watts a pair. So with regards to cable and wiring methodology, well, if you know how to do class 2, basically Article 726 and then the UL 1400-2, which I mentioned earlier is primarily a cable manufacturer's guideline or set of guardrails. Article 725, if you're familiar with those 4 pages in the NEC, well, now you can reread 726, which adds another 3 pages. And basically it reads the same. So the class 4 cabling installation just reads almost verbatim what you'll see in 725. So it says, you know, class 4 cables can be placed with other power limited cables. So you can mix in a raceway, class 4, class 2, fiber optic, EOE, cables in the same fashion. You cannot mix them with class 1 in the same way that you can't mix class 2 or class 3 with class 1, unless you have a barrier. The codes do allow, like within an enclosure, you can mix class 4 and class 1, but they have to be separated by at least 1/4 of an inch. And if you're in a raceway, you have to have a barrier. If you're in a raceway and you're outside of an enclosure, you have to have 2 inches of separation between class 4 and class 1. But it's the same story. You just treat it like the class 2 codes. And you can't use class 4 cables for anything other than class 4 unless they're listed for that application. So when you see the new class 4 cables, they really look a lot like a class 2. It's just that they're going to have a little bit of different labeling on them. They're going to explicitly spell out that they're UL 1400-2 compliant, or they'll also say CL4. And any of the cables for class 4 that are in the size range between 6 and 16 gauge, then the standard temperature ratings and ampacity adjustments that can be performed in Article 300, it's actually 310 specifically in the NEC, they still apply because those are pretty large cables, 6 to 16 gauge. So it's treated basically the same as a standard class 1 type cable. But when you get into the smaller cables, so 17 gauge on down to 24, those can be used for class 4. VoltServer uses a lot of 18 gauge in our designs, but on these new class 4 cables in that range, you'll see that they'll have special marking on them. They'll say FMP for fault managed power, and then they'll have a maximum current rating listed as well. So that is one of the differences on a class 4 is the labeling. Also, class 4 defines that you can't have a cable smaller than 24 gauge. So basically nothing smaller than Ethernet, which makes sense because cables that small are not very robust. So you generally want a larger cable just so that it not just for the copper, but just for the pulling capability and such. If you're pulling it through a riser or a plenum, you want it to survive. So generally you'll see cables that'll probably be in the 14 to 18 gauge and nothing smaller than 24. So we can see here how a standard cable would be installed. You'll have some transmitter shelves as defined earlier at the head end, which is where they'll take the power from the mains. And then in most cases, you'll see overhead raceways. This is how it's the advanced class 2 is done today. So in this case, you can see the green cables were a digital electricity advanced class 2 system laying right next to the fiber optic cables. That then can be shown there a raceway. It can be hanging from J hooks. It could be going up a riser, or if it's plenum rated cable, it can be going through a traditional plenum. It might be an underground direct bury cable if it's suitable for that application. And you definitely want to use the weather, indoor, outdoor, wet location cables if they're going below ground level. And if they're direct buried, you definitely want to use the ones that are rated for direct bury environments. And then at that remote end, they'll either go into a class 4 receiver or a fault managed power system receiver, or they may go into that utilization equipment, an embedded device such as that PoE switch up on top. So the cabling will be done just like class 2. It'll terminate into a receiver or a utilization device that just plugs right in. And then the loads will be served directly. And so that intelligent power system, that fault managed power system now typically is backed up because most of the time the AC power is from a UPS or a generator backed up system. And one of the advantages here is it allows everything on the fault managed power system to operate as a backed up critical power system, even if the rest of the wiring in the venue is not. So the customer may choose to use the fault managed power system just for its critical loads as a parallel system, or it might use it as a B feed, where the A feed is the standard traditional class 1 power, and the B feed or the hot swap over is the class 4. That's being done today with some of our customers' projects, and we'll see as more and more individuals bring fault managed power systems to market, you'll be seeing that more and more. And you'll see these come to market because there really are many advantages to a fault managed power system. As we mentioned earlier, it's safe. Everything, all the equipment's been tested by the nationally recognized testing laboratory, so it's all certified. It's all listed and labeled. It's the same wiring practices as power over Ethernet. So very simple, very robust. And with the new systems, as we mentioned earlier, they can handle significant power. So, many hundreds of watts per pair of conductors, not just 70 watts or 30 watts like you might have with PoE and its variants, PoE plus, PoE plus plus. But you're now looking at many hundreds of watts terminating into a receiver device that may take in multiple channels and may on its own, a single receiver may produce a couple of kilowatts as we do today. And running that significant power safely, you can go significant distances. You can go thousands of feet instead of hundreds of feet. Traditionally, a class 2 power system for PoE might go, 100 meters, so 300 feet. Class 2 wiring on, say, 12 gauge may get somebody out to 1,000 feet. But if you want to go thousands of feet or 1 or 2 kilometers, you really do have to use the fault managed power system. We talked earlier about the skinny conductors, so a lot of savings there in copper and plastic. generally 14, 16, 18 gauge as opposed to the larger copper conductors. These intelligent power systems can monitor and control beyond just the automatic safety monitoring of the class 4 circuit. They also can do power logging. You can do policy control if you want to do load shedding. So the transmitter does more than just digitize power and send it out. It's really an intelligent control system that will log power and do a variety of things that a traditional circuit breaker can't. By using the same pathway cable as fiber, or maybe using a composite cable that has power and fiber in it, the speed of deployment is increased because you're just going up and laying a single cable in a raceway, as opposed to bending EMT and core boring concrete and and trying to pull multiple conductors through multiple runs. It's a lot easier just to lay something up in a raceway or hang it from J hooks. And as I mentioned earlier, it's a somewhat sustainable technology in that you're saving copper because the system runs at a higher voltage, therefore smaller conductors, less copper, less mining. We can all save some money, which is kind of good for everybody. So that's kind of where we're at. So just in a nutshell, once again, a class 4 or a fault managed power system is a system that monitors the circuit for faults and takes action if it detects a fault extremely rapidly. And the wiring methods are exactly the same as class 2.
Questions, Rob?
Yes, Mike, if you're done, I'll open it up to questions. Feel free
Yes,
to
absolutely.
ask, unmute yourself if you have a question, or use the chat function, and Mike will help.
Yeah, Mike, this is Jim Dollard. Thank you very much for the presentation. And we were anxiously awaiting VoltServer getting on an industry hour with us, because this is something that NECA contractors need to be aware of. Now, in February 2025, we're going to move to the 2020 NEC. So we're looking at 2028 before we get
Okay,
to 2023.
sure.
But we all know that we're going to see new technology entering into our market before adopted codes and standards may
Yes,
be in place. So just know that we can through special permission allow these systems to be installed. So it's not something that we can look at and say, well, we're not going to be able to do this until 2028. The other thing is that we wanted everyone to be aware of what a class 4 system was, what a fault managed power system was, because you're going to hear about it. Now, it's not going to change our entire industry, but certain things that we do are going to change dynamically. So, Mike, the voltage drop savings here are very easily seen by this group. Could you just give us some examples of typical applications of a fault managed power system where a receiver is required, and then give us some examples of utilization equipment that you're seeing that
sure,
has a receiver built into it?
sure. That's a good point. So just as a little bit of background, VoltServer has been doing this for a decade. We have over 1,000 signature venue deployments. What I mean by that is airports, stadiums, arenas. If you've watched the Super Bowl for the last 6 years, well, 5 of those stadiums have had all their telecommunications powered by digital electricity, a fault managed power system. Airports, big shiny office buildings. And so every one of those uses that transmitter and receiver methodology. So probably 98% of the deployments to date have had either an AC or DC powered transmitter shelf running through class 2 cable. And in the past, what we've had is since UL 1400-2 didn't exist until just recently, basically we would do our own testing on class 2 and class 3 cables, and we created an approved cable table that allows customers to go and pick cables that are suitable for our digital electricity, which, as I mentioned, is our version of a fault managed power system. And so all of those have receivers. Then those receivers may be DC powered, powering large 24 or 48 port switches, which then those switches may be powering PoE cameras or other types of controllers. There's a large deployment at the Circa Casino in Las Vegas where we're powering the Aruba switches, the GPON in each room. We're also powering their DAS system, their distributed antenna radio system. We're powering some of their LED lighting, and we're also powering some of their LED emergency lighting. So each of those locations have a receiver. Now, the lighting and emergency lighting locations actually have an embedded VoltServer receiver into a Class 2 hub from a company called Edge Power Solutions, or EPS. They're based out of Florida. So they were the first ones to embed a receiver into a device. So they were the first application of utilization equipment. And today, they also have a new version that is brand labeled through VoltServer that is a Class 2 hub that takes it has terminal block on front that takes up to 4 channels of digital electricity in the fault managed power and provides Class 2 56 volt ports out the front as well. So it can operate like a little power system. So the fault managed power system is backed up, feeds the Class 2 hub. The Class 2 hub then can feed 16 channels of Class 2 power out to the loads. So that's one version of utilization equipment that's being done today with an embedded receiver. Another is there's a company called CommScope, which focuses primarily on telecommunications gear. And they have a product called the Constellation that's also a very advanced Class 2 hub because it does more than just send out power. It can convert power into various formats. And it is an example of utilization equipment as well. It takes digital electricity in, converts it to both DC and AC, and is also a fiber hub. So they have a very intelligent device that's powered by DE. So there are, if you walk around, you never know it, but probably half of the airports you go to have their radio systems, their C-band, their 5G, their LTE radios powered by a fault managed power system that is hardened so that if there's any type of disruption in the airport's power, that people on their phones will still be able to communicate. Emergency services, Department of Defense, first responders can still communicate throughout the airport and to the airport because that system is hardened and backed up. So today, most of the applications are in telecommunications, but we're seeing a large expansion into safety. Blue light poles on college campuses, for example, the panic poles, so somebody can go up and hit a button if they think something bad is happening or has happened. Many of those are being installed using fault managed power systems and with cable that's directly micro trenched into the asphalt. So it's a very quick to deploy system where they can go in, they can cut through a parking lot, cut a couple inches down, put a direct buried cable in, and that cable is protected because it's being sourced by a limited power source, and it's providing significant amount of power to the poles because they have lights as well as alarm communications on them. And that's just a simple example of what's being done today. There are a lot of other examples, but I didn't want to hog up all the time.
Yeah, Mike, this is Jim. Thank you very much for that explanation. And I would just like to point out to everybody that in the 2023 code, there is also a new section in Article 700.27 for Class 2 powered emergency lighting systems. So we're going to begin to see those, even though we may not get to the 2023 until 2028, and it won't be long until you see Class 4 fault managed power systems doing the same. Thank you very much, Mike.
Thanks, Jim. Yeah, so just real quick recap is, even if your jurisdiction hasn't adopted the 2023 you can still deploy these systems if they are listed as a limited power source through UL CSA 62368-1. So there's nothing stopping you from deploying.
All right, Mike, looks like we're a little over our 30-minute cap. So I'm going to wrap things up. I really want to thank Mike again for his time today and for Roger from VoltServer for hopping on. Like I said earlier, this is being recorded and it'll be on the chapter's website. I will send a follow-up email with Mike's presentation and his contact information. So if you do have any more questions, please reach out to Mike. And thanks again for everybody to hopping on. Our next month's industry hour will be, or industry 30 will be with Kojo about implementing business software. So please join us then. With that, everyone have a great day. Thank you.
Thanks, everybody.